On a clear, dark night, if you know exactly where to look, you can see it with your naked eye. A faint smudge of light, not a star, not a planet, a galaxy. Andromeda. It's the most distant thing the human eye can see unaided, 2.5 million light-years away. And when you look at it, you're not seeing it as it is now. You're seeing light that left it before humans existed, before we'd even split off from our last common ancestor with chimpanzees. It looks so close, so touchable. It is not close. And here's the uncomfortable truth this video is about. We are never going to reach it. Not in 100 years, not in 10,000. Maybe not ever, not in any form we'd recognize as us. Let's talk about why.
Let's build up the scale, because our brains simply aren't equipped to process numbers like 2.5 million light-years. The Moon is about 240,000 miles away. Apollo astronauts got there in 3 days. The Sun is 93 million miles away, about 400 times farther. Light takes just 8 minutes to cross that gap. Then comes our nearest stellar neighbor, Alpha Centauri, about 4.2 light-years away. Voyager 1, the farthest human-made object in history, has been traveling for more than 45 years. And even at its speed, reaching Alpha Centauri would take roughly 70,000 years. Now make the jump to Andromeda. It isn't a few light-years away. It isn't a few hundred. It is 2.5 million light-years away. That's roughly 600,000 times farther than Alpha Centauri. If Voyager 1 were somehow heading toward Andromeda at its current speed, the journey would take longer than the universe has existed several times over. We're not talking about a long trip. We're talking about a journey that doesn't fit inside the lifespan of stars, let alone species.
Okay, you might say, so we need faster ships. Let's be generous. Imagine engines far beyond anything we currently have. Nuclear pulse propulsion, fusion rockets, even theoretical antimatter drives. Suppose we could sustain 10% of the speed of light. That is already absurdly optimistic. At that speed, reaching Andromeda would still take about 25 million years. What if we went even faster? At 50% of the speed of light, the journey would still take around 5 million years. And then we run into a deeper problem. The faster you go, the harder it becomes to go faster. Accelerating a spacecraft to a meaningful fraction of light speed doesn't scale linearly. Relativity punishes you. As your velocity approaches the speed of light, the energy required to accelerate you climbs dramatically. You can get closer and closer to light speed, but you cannot reach it. And getting anywhere near it requires an amount of energy far beyond anything humanity can currently produce. So, even in a science fiction level scenario, we're still talking about millions of years, using engines nobody has ever built, at speeds nobody has ever approached. And that creates the next problem. What exactly would be making this journey? No human being survives for millions of years, so any realistic attempt becomes a multi-generational project, a generation ship. The people who arrive would be distant descendants of the people who left. It sounds plausible in science fiction. In reality, it would be a nightmare of closed-system engineering. You would need food, water, oxygen, waste recycling, an entire self-sustaining ecosystem that works not for decades, but for millions of years. Then there's genetics. A population small enough to live inside a spacecraft could face serious problems with genetic diversity over generations. You would need enough people or sophisticated genetic management to prevent biological collapse. And then there's the human problem. Imagine being born inside a spacecraft. You never see Earth. You never feel an open atmosphere. You live your entire life inside a machine built by people you will never meet. Then you have children. They grow up there. They have children, and the cycle continues for thousands upon thousands of generations. Even if the ship somehow survives perfectly, no catastrophic equipment failure, no unrecoverable accident, no war, no societal collapse, something else changes: the people themselves. Their culture would change, their language would change, their biology could change. By the time they arrived, they might be so different from the people who left that calling them humanity would become questionable. In a very real sense, we wouldn't be the ones reaching Andromeda. Some distant descendant species might.
And here's the strange twist. In one sense, the universe is already doing part of the work for us. Andromeda and the Milky Way are moving toward each other, pulled together by gravity. In roughly 4 to 4.5 billion years, the two galaxies are expected to merge. So why don't we simply wait? Two reasons. First, the timescale. 4 billion years is longer than complex life has existed on Earth. Waiting for Andromeda to come to us isn't a shortcut. It's simply trading one impossible timescale for another. And then there's an even bigger problem. Our sun won't remain suitable for life on Earth for that long. In roughly 1 billion years, the sun's increasing brightness is expected to make Earth increasingly hostile to life, long before the galactic merger. So, whatever future humanity has, it probably isn't going to be, let's just wait for Andromeda.
To be fair to the dreamers, never is a very strong word. Physics doesn't necessarily rule out every possibility. There are speculative ideas such as wormholes and Alcubierre-style warp concepts that would manipulate space-time rather than simply move a spacecraft through it. But there is a massive difference between a mathematical possibility and an engineering plan. These concepts currently require forms of energy or exotic matter that we have no evidence we can actually produce or control at the necessary scale. So for now, they're fascinating ideas, not technology. But there's another possibility. Maybe human biological beings won't be the ones making the journey. Imagine humanity eventually creates self-repairing, self-replicating machine intelligence. A machine doesn't need food, it doesn't need oxygen, it doesn't need to sleep, and it doesn't care if the journey takes 10 million years. That changes the equation completely. So here's the honest answer. Reaching Andromeda on any timescale that matters to human beings living human lives is not happening with the technology and physics we currently understand. And if anything eventually crosses that gulf, it may not be humanity in the sense that word means today.
There's something almost beautiful about that faint smudge of light being permanently physically out of reach. It's not a wall we can push against. It's not simply a problem waiting for the right engineer. It's a fact about the scale of the universe, about how enormous space is, and how short our existence is by comparison. We may never stand on a world orbiting another galaxy's star, but tonight you can step outside, look up, and see light that is millions of years old. You can look directly at another galaxy and know exactly how far away it really is. That's not a small thing. That might be enough. If you enjoyed this video, subscribe to Space Chronicles for more stories about the scale and mysteries of our universe. And let me know in the comments, if you could make the journey to Andromeda, even knowing you would never return, would you go?